A common analytic problem is to uncover discrepancies among two data sources which should match. We are going to build a model which implements this analysis and reconciliation and perform some simple analytics on the combined view. We can easily acquire data from a variety of disparate sources, such as databases, spreadsheets, complex file formats, delimited files, and more. We place nodes from the palette onto the canvas and configure them in a node editor, such as this DB query node that acquires customer data from a database. These nodes that we are placing on the canvas acquire data or accept data from inputs of other nodes or other sources, such as a spreadsheet in this case, and perform some activity, then produce one or more outputs reflecting that activity. These nodes are executed, and the records are then displayed on outputs available for inspection or processing by other nodes. Next, we place the xref node in our canvas. As with the traditional database join, we choose a common key and compare data sets and produce sets of matching and non-matching records. Unlike a SQL-based join, however, our xref requires no coding and immediately produces left, right, and inner sets along with record counts, which quickly allow us to easily inspect the results and create a separate analytic path as needed for each result set. In this case, data from one side are missing vital information. We can take the results that did not match and attempt a second match using alternate criteria. Here we will attempt to match the flawed records that did not contain a customer ID. We can inspect the fields available and choose what we think might be appropriate, such as the customer's phone number against the number that was used to make the order. Executing the node, we can instantly see the results are not as expected. We can inspect the data quickly and realize that some data manipulation needs to be applied so the phone numbers can match. The ability to inspect results, test configuration changes, and iterate quickly while interacting with the data enables a discovery and validation process that can produce results you can be confident in and improve your understanding of the underlying data. Once we make the necessary changes and rerun the node, we can see the results are matching as expected, and we are able to continue quickly growing our model by iterating through each stage interactively. Because of the visual inspection, we were able to identify and correct incomplete requirements which otherwise would have led to a flawed downstream view. We now have a visual model of the joins required, which allows us to trace the data through our manipulations, providing a structure with easy visibility and adjustment to any new outliers, adapting to changing data or changing requirements. We can take the results from both correlations and, confident in their accuracy, create a combined output that is ready for further analytics. Next, we can create an aggregated view of each customer, totaling up all the purchases each customer has made. We can drop, add, and manipulate fields in our data using BrainScript, which has a syntax and set of operators similar to those provided by SQL or Excel macros, including functions for common tasks such as string manipulations and complex calculations. A common operation is to segregate the data based on some condition or value in the data. This again allows multiple paths to be exposed to the model, or isolate specific subsets of data while retaining the full set. At any time, data can be published out from the model to common destinations including spreadsheets, databases, delimited files, email, and more. This enables results to be easily shared or placed into corporate workflows or existing dashboards. Because of the flexibility we provide in manipulating the data, you can create different views of the data easily, making use of a wide variety of nodes available in our library. Additionally, nodes can easily be combined and packaged by the user as reusable assets, so a user can develop their own libraries of high-order constructs as well. Once you have the data manipulated the way you like, you can visualize the results directly inside the tool using our inflow technology. The data can be rendered in a multitude of ways, allowing a visual discovery and communication opportunity that is side by side with the model, therefore inherently traceable through all calculations back to the source data. This enables Lavastorm desktop technical and business users to collaborate together right in the model. Within a few minutes, we have performed a reconciliation of two data sources, performed some analysis on the outputs of this reconciliation, and published the results as tabular and graphical outputs. Instead of mere source code or a set of scripts, we now have a visual model of this analysis which can be easily described as a sequence of logical operations and which can be enhanced and augmented as data and rules change.